Okay, so we're back to using the same curve, this hyperbola over here. And what we want to do is approximate the area underneath using the right endpoint approximation now. So we're going to be using our REP. Okay, so just to talk about what the problem looks like first. Of course, you don't need to draw this when you're doing the problem when you're practicing, but it's a good way to see if the whole procedure is done correctly. So over here, just draw our hyperbola real quick, something like that. And we're going to go between x is equal to 1 and x is equal to 3. What we're going to do over here is split this up into seven rectangles, into many rectangles that all have a width of 0.5. So we have 1.5, 2, and 2.5 down here. We need to form rectangles using the right corner. So that means when we form our rectangles over here, the right corner needs to touch the curve, and from there we can form a rectangle. Now the right corner can hit it over here, form another one. So all these rectangles need to be enclosed between x is equal to 1 and x equals to 3. Okay, something like this. And if you want to find the area of all these rectangles, we can do something similar to what we did in the LEP, the left endpoint approximation. We know that over here, this coordinate is 1, f of 1. Then we have 1.5, f of 1.5, and so on. The point is, we need to know that we end at x is equal to, this is why we draw out all of our coordinates over here, because we can easily get mixed up between LEP and REP. Over here, this coordinate isn't x equals to 1. This is x equals to 1.5. So what we actually need to do is we need to start at x equals to 1.5. And all of these points are going to be spaced 0.5 from each other. And we need to note to ourselves that we're ending at x equals to 3. And our y value is f of 3. So when we find our area, this is the width of 0.5. So this is width. And we're going to multiply it by all of the heights. So over here, we have f of 1.5 plus this one over here, which is f of 2. That's the height of the second rectangle. The height of the third rectangle over here, we've got f of 2.5 plus f of 3, which is this last one over here. Now, when you sum up all of these, what we're going to end up with is, well, you can use fractions over here if you want to calculate all of this, but just say that this is tech active for now. So again, we can define f of x as the hyperbola, and if you want to find the area, we know that this is 0.5 multiplied by the sum of all heights. So this was f of 1.5 for the first rectangle, f of 2 plus f of 2.5, and for the fourth rectangle, which has a height of f of 3. Summing up all of these together will give you 19 on 20 square units.